Hi everybody, hope everyone's having a great day. In this video I'll be talking about Cloud 9 and beyond, which sounds like a fantastically bad science fiction movie, but it's really about how once we develop something on Cloud 9, how we're going to deploy it. So Cloud 9 is a web IDE for really developing anything, but really for developing web apps. And well, it says it right here, your development environment in the cloud. And as it scrolls through all these wonderful things, it really does seem to suggest that it's good for doing development work, but in nowhere in any of these things does it talk about, you can develop in here and it hosts your site as well. As we've seen, it doesn't stay open. Here's one that says web development was never so easy. So the little virtual machines we create don't stay up all the time, but they do go down, as we've seen sometimes when we are away from Cloud9 for a short while, and then we have to wait a while it reboots our little virtual machine. So there are times, though, that we want to move away from just development and actually deploy something. So we might want a personal website. That's really helpful. A good way to advertise what we know what to do and what our thoughts are. And a lot of people say, especially for computer science students, that it's really a good idea to have this when you're looking for a job, to have a personal website. Having a cloud-based server somewhere is also a great place to try some ideas that you have. You read about something like maybe Docker containers and you want to give it a shot. So it's a good idea to have one of these servers. Or maybe you just want to develop you have an idea for some web app that really helps a lot of people. Or maybe you have a web app idea that you think, well, my God, I can really earn a lot of big bucks this way. Or maybe ideally you found a web app idea that helps a lot of people and you can make these big bucks. So there's lots of reasons why you might want to have a hosting service and not just be developing in the cloud. So there's lots of places you can go to get some of these services. This is not one of them. I'm just doing this for comparison's sake. Before you worked with Cloud9, you may have thought, what can you do with 512 megabytes of memory? Hardly, I don't know what you'd point to in modern life that would have such a limited amount of memory, or only a 1 gig hard drive. But I hope you've seen, doing these rudiments and stuff, that really you can do a fair amount of stuff with such a limited machine. The closest things we have to that might be this Amazon EC2 Nano instance, and that runs about $40 a year, has the same amount of memory as we've been using. These question marks here for Amazon mean that persistent storage in Amazon is a separate charge. It's not very much, but it's not included in this base 320, so that's why I put those there. Here's another one that's pretty similar. For only $60 a year, you get 512 megabytes of memory, this 1-core processor, and a 20 gig solid, so a pretty fast hard drive being a solid state one. A little step up are these two. DigitalOcean and Linode have very similar offerings in this space. Amazon EC2 Micro, kind of in between all this. This is where I started my Zaharsky.org site whenever it was, years ago, and it ran on this for a good while. And my Lightning Round software originally ran on a micro, then I moved it up to a small and then a medium, and now I think I'm running on a large. But what's nice is that you can resize things. It's fairly painless to do resizing. And the other great thing about the micro is that it's free for the first year. So you give credit card information, a variety of things there, and then you get it free. So that's really a cool way of exploring some of this technology, learning about how to do things in the cloud. And even at this price, which I think might be, is it $80 or less a year? It's a pretty small amount of money. As I said, I started with the micro. This is where I am now. There's services like this other places, but all these up above here are really virtual machines. So you get a virtual machine with these specs, and you're on one physical machine with other people. And when you're not doing something, some other person's using that machine. So you're kind of like sharing through using these virtual machines, or a lot of times these Docker containers. So many people on one are on one physical machine. This is a service where you get one physical machine sitting in a rack in some city far away from you. So this is one of many companies. And I'm using, let me find the one I'm using. I'm using this one here. So I have 32 gigs of memory. I have a rated 2 terabyte hard drives. This processor is pretty fast, 4-core, 8-thread, 3.4 gigahertz. You can kind of click here and see the offering. So something like this would be good if you're doing a lot of scraping. So if you have this great web idea, and by the way, there's lots of I just don't host Arskit.org on here, but there's lots of sites that or not lots, but my sites, a bunch of sites are hosted on here. And if you're doing something like scraping the web, so like you're grabbing stuff from Netflix, or you're grabbing stuff from Twitter and doing some analysis, or from Amazon. So if your ideas involve that sorts of things where you're grabbing lots of information and needing to store it in a database, you certainly need that storage space and that processor speed. And this is far cheaper than any comparable thing on Amazon or DigitalOcean. So this may be a place in the future you may want to go, or maybe you have a need now. But in general, it's these fewer or these smaller machines that you might be interested in. And it's real common these days to talk about coffee currency, which is that for the price of a latte. And the one here would be, well, for the price of one latte a month, you can get access to have a server running, which seems really pretty cool. At least it seems pretty cool to me. Google has lots of offerings. I've never used them for smaller things. I don't know what they offer in that space, but I've used them when I've needed, like having 6 machines in a cluster or something. They're for short periods of time. They're really kind of a good way to go, and they also offer some free deal. That's how I ended up getting a couple $100 of compute time from Google to explore stuff. So with all these possibilities, which to choose? Well, Amazon is slightly more complex registration process, not much, but you're not going to get up and running in about 5 minutes. You're going to do some reading about how to get registered. Once you are registered, bringing up new machines, managing, I've done this registration a couple years back or more than that, and now it's painless to bring anything up. This DigitalOcean and Linode are real kind of modern ease of getting things up and running. You just, to get an account, you give it your basic information, your billing address, your credit card information. In 5 minutes you're ready to go, and in 10 minutes I think you can develop a site. We'll see if that's true. I'll be doing that in the later part of the video. And if you're interested in kind of the DevOps area and DevOps jobs, knowing about Amazon Web Services would really be a big plus for your resume, and knowing not just having this little running in little nano, but really kind of exploring, well, what happens when I bring up multiple machines and do load balancing, or how can I work with CloudFormation? So if you're kind of curious about these things and want a DevOps job, certainly Amazon's the way to go. And let me just talk a little bit about DevOps in general, and just so you get an idea, maybe that's a new term, maybe not for you, but let me talk about DevOps. And this is a detour from my main topic. So in the past, how things worked was, in computer science, they like to talk about, well, at least in the development world, they talk about silos of things, these hard, concrete, big silo things. So you have all these software developers sitting in their concrete silo, working on some massive project that they release. It takes a long period of time for them to release it. A year, 2 years, they're developing some system that does billing for hospitals or whatever it is. They work for a year. Then they pass it off to the IT guys who are sitting in their silo, and they're the guys that know how to deploy it on servers and do stuff like that. So this model of actually having kind of a big finished product is what drives this silo idea, right? You work really hard, you get this product, you give it to some other guys. In the startup world, and in general now, as the startup ideas start to trickle across, things are much more dynamic. And like we've seen in Scrum, where we're not working for a year before we release something, but very quickly, in a month, we're releasing some preliminary product. We stick it on some servers, running some tests. Maybe we'll have some beta testers. So this membrane between developers and the deployment people is really much more porous. There's more vague, cloudy, fluffy stuff between there. It's not this hard concrete barrier between developers and the people who are sticking it on the servers. So these are the DevOps people. And think of it this way, of the complexity involved is, suppose you work at a startup and there's like 10 people working at this startup. And let's say you are working in Cloud9, and your idea is, you have this idea and you think, well, in a year, I bet like 100,000 people will be visiting the site in a day. And really, that's not too far-fetched. I mean, Facebook has 1 billion users a day, so 100,000 doesn't sound like a lot. So you develop this stuff on Cloud9. Well, you're not going to deploy it on one machine on Amazon or DigitalOcean. You're not going to have 100,000 people accessing the equivalent of one laptop. Right, that's going to bring this laptop to a screeching halt. So what you do is you distribute your code, your identical code, across a lot of machines. So you get 20, 30 machines going, or not initially, but eventually to get this load. Now when someone visits your site, there's a load balancer sitting in front of it. That's this term up here. So Ann comes to the site. This machine routes Ann's request to some server, some physical machine. Ben comes to the site. His is routed somewhere to some other machine. To the outside, it looks like one machine. So when I visit Amazon, it looks like one, or my conception of it is that there's one large Amazon machine that's giving me the shopping experience. Not that I'm connecting to one little server somewhere, and when someone else visits the same web page as I do on Amazon, they're operating in a completely different machine that's running just the identical software. So that's how it works. We need this load balancer in front of a bunch of machines running the software. Now, let's say that's a Flask app accessing Postgres. Now, all these servers aren't going to be accessing a Postgres server running on a single machine as well. So we'll need to distribute that database across multiple machines. So now we have multiple machines running Flask, our Flask app, multiple machines serving up our data. And that's the space where these DevOps engineers come in. They know all about how to do this, and it's a pretty exciting thing. The other interesting aspect is that all these machines in this cluster, of how we've arranged them, may dynamically change as the day progresses, or as the days in the week progress. So during the day, when we have lots of traffic, all the machines might be going to whatever the app is. At night, when things are quiet, some of those machines might do data mining things like scraping the web, or doing analysis of our customers in the day, or indexing things. So the function of a machine may vary as the day progresses. So things are real dynamic in this space. So for a DevOps job, a lot of DevOps engineers come from a software engineering background, and you certainly need the ability to code and do scripting. That's really an important part. You need to know about virtualization technology, like these Docker containers I keep mentioning and never explaining. But if you're interested, check them out. They're cool. And it's certainly a way that an area where that's growing, and it's kind of a hot area. You need to know about all these things I mentioned. Load balancing, cloud formation is how you're distributing work among this cluster of computers, and other techniques like that. You need to figure out, well, how am I going to deploy this code that the developers are developing onto this whole clustery of computers. And you also need to know about database stuff, of how can we distribute or shard the information across a number of computers. Now let's get on to our main topic of looking how to deploy our application. Before I do that, though, I need to kind of backstep. So not exactly a detour, because we're going to need this. And I think it's something most people know, or at least some people know, but I just wanted to make sure we are kind of on the same page with SSH. So I wanted to talk about SSH for a bit. And most people have used, I think all of you, I'm assuming 100% of you have used SSH in some form. Whoops, but I don't want to do that. But one thing it relies on, or a lot of SSH relies on, is this idea of public and private keys. So here are my private key for SSH and my public key for SSH. Now, SSH is pretty interesting. It relies on a number of these different keys. So when the connection is originally made, they agree upon a set of keys, these symmetric keys. And what that means is that if my laptop's trying to connect to my server in Quebec, then they exchange these keys. So a message from my server, so something that's going to appear on my terminal, will get encrypted on the Quebec side with one of these keys, gets sent over to my desktop or my laptop, let's say, and my laptop has a key that can decrypt this information and can encrypt another bit of whatever I type, and that's encrypted and then sent to my server there in Quebec, which then decrypts it. So it's this symmetric encryption, decryption on both ends. Sometimes it's nice to have to know, so my server in Quebec's there, and it has to know that, this laptop can connect to that server in Quebec. And commonly what we do is we type in a username and password is how SSH is handled. But there's another way of identifying a trusted laptop or a trusted computer, and that is through these SSH keys, these public and private keys. So how that part of the scheme works, so we've made this encrypted connection using these symmetric keys, and now these two keys are asymmetric, and that means this, that I give this ID RSA pub to various places I want to connect to. So my server in Quebec and wherever else, I hand out my public key, and let me just show you that. It's just a long string of stuff. That's my public key. So I give that to initially when I set up my account there. And what that server does is it encrypts a message using this key, this public key, sends it off to me. Remember that I'm already in an encrypted channel because of those symmetric keys. These are within that encryption. It encrypts it with this, it sends it off to me. I can decrypt it with my private key. So I decrypt this message that it sends, and then I send back to the server what I thought, what the results were after I decrypted it. And that's how, and only this private key can decrypt messages sent by this, or encrypted by this public key. So that's how the server knows that I'm a good trusted laptop. It encrypts this message, sends it off to my laptop. My laptop decrypts it with the only way it can, with this private key. It sends it back. This is what I think your message is. And that verifies who I am. So these keys are an important way of trusting people without doing passwords. So let me just show you how to do that. Now I'm in my virtual machine, my Ubuntu machine. Let's make sure I don't have those. The only thing in that directory is this authorized keys. All right, and how I generate a SSH key is I just go SSH key gen, and I always keep this the same. Type in a passphrase. And now let me just up arrow here. You see I do have those two keys. So that's how you generate one of these key pairs. Just use SSH keygen, and we'll see shortly when to use them. All right, cool. Let's go on. Let's go to Cloud 9 here. All right, so what I've done in order to do this demo is create, well, not a very inventive name. I created this folder called Demo, this app, and what I wanted to make sure was that I had an app that used Flask a little bit and also used Postgres a little bit. So then I could demo kind of what's involved in installing this stuff on a server. So the demo's not all that exciting, but at least it hits those two requirements. Let me just get it running so you can see what it looks like locally. All right, so it's just start the day, quotes to make you think. All this stuff here is coming from that Postgres database. All right, so just quotes. The whole process of nature is an integrated process of immense complexity, and it's really impossible to tell whether anything that happens in it is good or bad. So not an impressive site. It's not meant to be. It's just a way of demoing the important parts, Postgres and Flask. All right, and let's go to something we know, I'm assuming people know, is I'm going to, whoops, not there. I'm in that directory, and now I'm going to create a Git repository for this project. So I'm adding all the files to there, and I'm committing them. All right, so that should be good. Let me just make sure. All right, that looks perfect. All right, now I have everything committed to a local Git repository. Now I want to push that repository off to some repository in the cloud. If my laptop dies or I want to share this with someone, it'll be there. And the traditional way we do this, of course, and which all of you are familiar with, is to use GitHub. And most of us are using the free version of GitHub, which doesn't allow for any private repositories. And there's a number of security problems with putting code up to a GitHub repository that several people, at least there's some pretty interesting articles in the press about developers who put code on GitHub that contained usernames and passwords. And you see right up here, I have that. I have user start today, password, blah, blah, blah. And I didn't really finish my explanation. These were developers who put code on public GitHub repositories that included username and password. So anyone could read them and log into databases and all other stuff. Some test log in as administrators to some code, and so on. So you see that would be really pretty problematic. So I could take these out before I commit them and then just remember to put them back in. That might be, especially if I want to share my code, that would be the way to go. But I'm just going to try something different here. I'm going to use my Bitbucket account and create a repository there. And there I can have private repositories. So let me go ahead and do that. I'll call it my demo. Oops. What I wanted to show before was that I have a choice of Git or Mercurial. I've used Mercurial. Some people say it's a much better versioning system than Git. But the problem I had was I was also using Git at the same time, and I could never keep straight which was which commands were which. So I just kind of gave up and went with Git for everything. If you're interested in Mercurial, there's a great write-up about it, great tutorial written by Joel Spolsky. I think it's Spolsky, Joel, Joel. So if you see if you're going for a job interview and they use Mercurial, you might want to kind of check that out. All right, so I'm back here at my repository. I've already created an existing project. I never remember these commands, so I just do my cut and paste here to connect the local repository to my Bitbucket one. Let me go ahead and do that. And there's one more command I need to do. All right, and hopefully when I go here and look at my files, they're all there. So that's cool. It's, as you see, it's pretty similar to GitHub. Let me just show you that that's true. So let me change this comment to time to connect to DB. Not important why, but I just wanted to make a change. So if I do git status here, it says that I modified server PY. So this is my method. You probably have a better method of doing this, but and now this is the part I really wanted to show you, that it's the same as using GitHub. So I just do git push here. And if I go back to my Bitbucket account, do a refresh, you see that that server PY got updated just like it is in GitHub. So really no difference. they're similar services. This one allows for private repositories. All right, so that's good. And I think now I have all the preliminaries out of the way. So let's go ahead and create a account here for a system, a machine in DigitalOcean. All right, and I've already been logged in, so that's why I get to this screen. As I said, the registration was fairly easy to put your name in and your credit card information. And droplets are what they call really Docker containers, which you can consider to be virtual machines. So I'm going to create one of these. And I have a choice here of what kind of machine to make. I'm going to go with Ubuntu. I could go crazy and get 64 gigs of memory at $640 a month, but I think I'll go with the $5 a month option. Here's where I choose where do I want the machine to exist. New York sounds like a pretty good idea here. I have options here of what kind of networking and stuff I want that I don't need to deal with. I'll use my existing SSH key, but let me put in a new SSH key. And now I don't know why I'd ever want to do this, but let me change my directory here. I didn't want to do that. I wanted to do the cat. So I just copy that. And paste it, and I can call it whatever I want from Cloud 9. So I don't know. So if I ever want to log in from Cloud 9, I can do it. I just wanted to show you what that was like, but we'll go from there. This is how many of these machines do I want to get up and running. I just want one of them. And let me create a name that I like. I'm going to pick this name. I like it. All right. That's not the way to go. All right. It's creating this machine. Man, that's fast. 512 megabyte, 20 gig drive. Looks good. And in New York City. Cool. And we're still waiting here. It was going fast. Now it's slowed down. All right, neat. So here I have this IP address. That's my IP address of my machine. I'll rely on it being copied. All right, so here I am on my Mac. And I'm going to log into it. So SSH, I think root. And amazingly, I'm connected to this machine I just created. There's nothing there, but heck, it's my machine that's running in the cloud. All right, so the first step, now let's install Postgres. And before I install anything, let's just update those. Just make sure we have the latest information about things. This always takes longer than anything else. All right, so let's install Postgres. Sudo apt get install. So I'm going to install Postgres. It's 18 megabytes, sure, why not? Starting the server. All right, and what's nice about this now is that, in Cloud 9, we'd commonly have to go sudo service PostgreSQL start because they would bring down the virtual machine. Here, we never have to do that. If the machine goes down for some reason, when it starts, it'll auto restart the Postgres server. So we don't have to worry. It's nice to know that command, but really we don't have to worry about it with any of these hosting systems. All right, so then what? So let's just get everything finished, set up here. So I'm going to just change user to be Postgres for me rather than, right now I'm root, as you see here, I'm root. Just going to and now I'm Postgres, so I'll log into PSQL. And now what I want to do is set up my password. My new password is my usual change me. Just kidding. All right. So now that should be good. All right. Let me log in just to make sure that works. Okay, cool. Now I have Postgres up and running. All right, let's see what else we need. We need to install Flask. So let's do that. Well, before we do, we usually do, or I do it by using pip, but I don't think pip's installed. So let's do that. Sudo apt get install Python pip. Okay, so we're installing pip because we need pip to install Flask. All right, and now I'm going to install Flask. Sudo pip install Flask. All right, and now I want to install the Postgres adapter for Flask or for Python. All right, now I still don't have anything there. Let's get that code that I just wrote. So sudo, well, let's see if we have git. No. Whoop. All right, and now git clone. Oh, I need the. This is the part I can never find. Hold on a second. Ah, there it is. Let's do the HTTPS version. All right, hopefully I have it. Paste that in there. Now my password, which is for Bitbucket. Hold on, it's one of these complex passwords. Let's try it again. The disadvantage of having secure passwords here. All right, I think we're good. All right, so I have my demo here. All right, so now I have that site SQL that I need to read into Postgres. So let's do that. Let me go into Postgres. Oop. And all right, that took quite a while for some reason. All right, so I guess I have quotes. Let me just. Well, it looks like I have them there. All right, so I have that. Let me look at, I need to create my username, but I forget what those are, so I'm just going to cheat and go here because I demo. All right, let me move that up a little. Let me move that some more. Oh, let's do this. All right. Sorry, everyone. Okay. Create user start today. All right, and now I want to grant select on quotes to all right, and now I want to get that password. And that's a good question. Well, let's see if we can do cutting and pasting here. All right, let's see. Let's quit. Let's hope for the best. Let's just make sure. Okay, so let's just go Python server. Oh, I see a problem, but let's just give this a shot to start with. All right, 162. Oh, I'm going to keep that. Wait, I can use this address. Copy. Okay, cool. Now I have my site running on DigitalOcean. Let me fix, I don't like that 8080, so let's see if we can get that fixed. All right, and I really dislike Vim compared to everyone else in the department, who seem to be Vim supporters, but I use it just because I have to sometimes. Okay. All right. All right. Let's see if that helped. Oh. Okay, so now I don't need that port number. Cool. So now I have this all up and running. It looks fantastic. One problem is, though, if I log out here, as you can imagine, I'd have to hit Control-C, stop the server. So that's really not the way to go. So let me, for now, I'll just give you kind of the easy version. There are better versions that I'll introduce later. But one is to do this. So I'm going to go screen, and that will... Okay, so now I'm in a session that won't expire if I log out. So I can do here Python server.py. All right, and now my server is running, and I'm going to hit Control A and D. It means detach. So, and it says detach there. So I can do whatever I want here. And my server is still running even, and I'll prove that to you. All right, and if I ever want to reattach for some reason, let's say I want to shut the server down or reload or something, I just go screen reattach, and it'll go back to that server. So you can see that it's updating there. Control A, D, detach. I can do what I want. I can even log out. I'm logged out, but my server is still running. Let me log back in. Okay. And again, screen reattach. I can shut my server down. All right, so I don't know how long that took, but it certainly didn't seem like it took very long. And now you can give out your, hey, check out my site, 162.243.118.56. Well, that would work, but maybe you don't want that to give out numbers, you want to actually give it a name. So let me talk about that next. And for that, I'll go to where I have my information. So there's a number of sites that offer places you can buy domain names. And here you see I have a slew of them, some used, some not used. This is where I have most of my domain name stores. Sometimes I come up with a name that sounds good and I just want to hold on to it. Who knows when I'll need it. But let me show you. Let's say this one here I'm not using. So let's see if we can point that to my site. So here, this is the one I want to change, this A record. And I want to change it to, well, whatever that's, this site, I guess, that I just lost. Is that right? Let me just check that that's the one. Yes. Oop. Yeah, that would help, wouldn't it? All right. So now let me go actually and get my server running again, because I don't. And I'm going to detach. And let's call that good. All right, so now what happens is this usually takes quite a bit of time, or some time, so I'm going to come back. I'll refresh the video in a bit, but now is a period of waiting, so this connection between BuddhistPractitioner.org and this site that we just created is distributed across all these different name servers. So I think I'll need to wait and come and show you the video. I'll bring up the video once that's completed. That's it for now. So that took a lot shorter than I thought it would. So now when I go to BuddhistPractitioner.org, let's go, here. It goes to my website. So that is how it works. I mean, it's pretty simple. So I brought up that machine, got this IP address. So there's a lot of these companies that where you can buy domain names. I like this particular one. It's more money. My son uses another one that's a bit cheaper. I don't remember the name of it. But you just buy a domain name here. Let's find a domain name. Let's say I want to have Zaharsky.io. Whoa, I don't want to spend that amount of money. Here, for $5, I can get Zaharsky.online. Or Zaharsky.website I can get. So Zaharsky.me. So there's a bunch I can buy here. My Zaharsky.com. No, I don't think so. But anyway, so I would buy, let's say I have a better name, like zen.org. That can't exist. So I can buy that for $12.99. And then that interface, as I showed you before, works kind of, let me get back to my, works the same. So we see this whole list of them. These are the ones I've owned. Some are connected, like Compassionate Paths connected, Guide to Data Mining, things along those lines. I went into Buddhist Practitioner, and I just changed one entry here to get that up and running. These are if I have, I can let Google handle my mail, so I don't need to handle mail. So there's information how to do that on Google. So if you're interested in that sort of thing, just check it out. But really, you can see that it was dirt simple to get this working. So the total cost here, I guess, would be something like $60 a year, or if for that nano instance, $40 a year, plus maybe $10 for this name. I think my son pays like $8 per domain name or something. So shop around. So for hardly anything, you can get your site up and running. Next time I'll take a look at a free service. If you want just the basics website up and running, I'll show you that. Take care for now. That's it. Bye.